In the previous lessons, we learned how to use the periodic table to determine the relative size of an atom, as well as the ability of an atom to attract electrons or the amount of energy required to remove an electron from an atom, just using the periodic table. Well, in this lesson, we are going to look at how atoms combine together to make a compound. And this process is called bonding. Atom bond with another atom to make a compound. And in any compounds, all the bonds in that compound occur because of electrostatic attractions. Because of electrostatic attraction, atoms, they attract and they stick together as a compound to form molecules, which is another fancy term for compound to some extent. And this molecule will attract each other and form liquids or solid. And that's all because of the electrostatic attraction between negatively charged atoms and positively charged atoms. So negative attract to positive charges. And that's the key concept of electrostatic attraction. And we have a fancy name for electrostatic attraction. It's called the Coulomb Law. Coulomb is a scientist who discovered the electrostatic attraction. And basically this law states that you have positive Q times negative Q, and that's where the positive charge comes into play, okay? So positive, and that would be the negative. And we know that positive and negative combine together, or they get close together, they attract. And what else is being involved is the radius. So this is the radius. What does the radius tell us? That tells us the size of an atom, and that's important. Coulomb law basically saying that the attractive force, that means how strong they would like to get together and stick together, is based on the magnitude. And the term magnitude is talking about the number, okay? Magnitude a number. -2, is it 2 plus, 2 minus, or is it 3 minus? The charges of an ions. And the same thing, negative Q is talking about the magnitude of the negative charges. And lastly, R is the distance between the two ions. How big are those ions? Now, using the Coulomb law, we can determine that the primary factors that affect the melting and the boiling points. What is melting point and boiling point? Well, think of melting, right? That's from solid to liquid, or vice versa. And boiling point is from what? From liquid to gas, vice versa, okay? So gas to liquid or liquid to gas. In this case, the same thing. Solid to liquid or liquid to solid. And that's melting point and boiling point. So here's the key factor. Well, look at this Coulomb law. First of all, we know for sure it has to be the magnitude of the charges. So therefore, magnitude of charges of ions is the primary factors that determine the melting point or the boiling point. And we know that the larger the charges, the greater the attraction. So that's what happened. We have larger charges create a stronger bond, where smaller charges create a weaker bond. To illustrate, an ionic bond between 2 plus and 2 minus, like calcium oxide, Ca. Remember, calcium is in group 2a, so 2 plus, and oxygen is in group 6a and 2 minus. So we're there, are stronger compared to ionic bond between 1 plus and 1 minus. And we know that Na is in group 1a and Cl is in group 7. So this right here is a lot stronger than that one. Now, what happens when you have two ionic substances or two substances that have the same charges? That happens all the time. Well, if that's the case, we look at the size of the ions. And notice how this is division. So the greater the number here, that would cause a decrease in attraction. So the smaller it is, the greater the attraction. So in this case, charges closest together create stronger bond. That means smaller equal to stronger, because the distance between them is closer. Where charges farther apart create a weaker bond, and that tells you that larger compound would be weaker, okay? So ionic bonds between smaller ions are stronger, where ionic bonds between larger ions are weaker. Let's do an example problem. Rearrange the compound from strongest to weakest, okay? And the strongest would have higher melting point or boiling point, where the weakest will have lower melting point or boiling point. In this case, we have sodium chloride, calcium oxide, and aluminum nitride. And we know that sodium is what in group 1A, so it's plus Cl minus, Ca right here is 2 plus, O2 minus. And now with the ideas of memorizing the charges of ions is important. And Al is 3 plus and N is 3 minus. And that's just basically using the periodic table. If that's the case, which one would be the strongest one? Of course, Al, N would be the strongest, followed by CaO, followed by NaCl. Let's try another one. HCl, LiCl, and NaCl. And they all have Cl in common. But the one thing that's changed is right here. Well, we look at the trend on the periodic table. This is where hydrogen is, and then lithium right there, and that's where sodium is. So we know that going down the side increase, right? So increase in size, that means this is the largest one. If that's the largest side, it will have the weakest bond. So in this case, the strongest bond is HCl, followed by what? Well, followed by the smaller one, next, followed by LiCl, and lastly followed by NaCl. And this is the largest size. Now, let's look at this one right here. We have some random ions, positive and negative. We have plus 1 and minus, 2 plus and 2 minus, and 3 plus and 3 minus. Well, the strongest one is the one with the higher magnitude of charges. So, of course, we know that M3 plus and H3 minus will be a lot stronger compared to M2 plus, X2 minus. And lastly, the weakest one of all is between M plus and X plus. So in this case, we know that the greater the charges, the stronger the bond.